Hello friends, welcome to lecture 4. This is part 4 of mathematical physics paper solution of 2021, and this is of BSc first sem, BSc first sem, and this paper is said by Dibrugarh University, and I have already solved up to question number 9A in the last part, right? So today we are going to start from question number 9b, and we're going to complete this paper in this video. So it's part 4. So links of the part 1, 2 and 3 are given in the description box. Please watch them for the for other problems which are already done. Okay, so before we start, please subscribe to the channel if you are new to my channel, and share with your friends and hit the bell icon so that you get notified when new video will be uploaded. So now let's start. So this is question number 9b. This is 9b. So what is the infinitesimal volume element in spherical polar coordinate system? And also we need to compute the volume of a sphere of radius r using the expression for infinitesimal volume element in spherical coordinates. So here you see, suppose we have considered this is our Cartesian coordinate, and we have assumed a sphere. This is a part of a sphere. Here in this diagram it is drawn a part of a sphere. Actually this is not complete sphere, so which is in this quadrant, and here center is its center is at the origin O, so we have taken that way. So now you see, the equation of this sphere will be given by, so suppose we have taken a sphere, let me write that way. Center is at the origin 0 0 0, then the radius is r, suppose, then the equation is this. Equation of the sphere will be this, right? So in sphere, in polar coordinates, in spherical polar coordinates, x is equal to this and y is equal to this, and this is z, right? So if dr is the infinitesimal displacement and along r, and dr d theta is along theta, and dr sine phi is r sine phi d phi is along phi, right? So this is infinitesimal displacement along this r, and this is along phi, and this one is along this r d theta is along theta, and this is along phi, right? Then what will happen? Then the volume, very small volume element, this volume element here you can see, this is very small, right? This volume element, let me write it cleanly, right? Just okay. Then the very small volume element, this which is called a infinitesimal volume element dv, given by this r square sine theta dr d theta d phi. So this volume element is called infinitesimal volume element. That means very small volume element, right? So now here next part of the question is given that if the radius of this sphere is suppose r, right, then what will be the volume? How to calculate the volume from this volume element? So now let me show you how to do that. Now you see, if the radius of the surface r, sphere r, the volume of the surface, this is given by 8 into volume integral from phi 0 equal to pi by 2, from theta 0 equal to pi by 2, and from small r is equal to 0, from 0, that means radius from 0 to capital R, is given by r square. So into r square sine theta d dr d theta d phi. So here you see, actually volume of a square of this volume of you see sphere of this equation given by this equation, that is given by volume integral of this x square plus y square plus z square dv, right? So here this is nothing but what it is r square, right? And this we have taken this dv, that is dx dy dz in polar form, in spherical polar form. So that's why this dv volume element is this one. This is the in spherical polar coordinates. And when you integrate this element from phi is equal to 0 to pi by 2, theta is equal to 0 to pi by 2, then r is equal to 0 to capital R, then you will get the volume of the sphere. Just you will get out of 8 parts, 8 equal parts, you will get 1, right? Suppose let me show you in 3D. Here you see, suppose this is your coordinate system, 3D coordinate system. This is x, y, z, and these are the coordinates, right? If you have a sphere here, so it must have 8 parts, right? So this is one part. Here you see, look at this, one part at this coordinate here. So on this plane and on this plane as well, right? So similarly, because here you see this coordinate system will divide this sphere into into 8 equal coordinates like this way. A shape will be something like this, right? So if you can imagine, right, in 2D plane it is difficult to draw, right? So each part will be of this shape, as I have taken here. This one will be the shape. This is in one quadrant, right? So similarly you will get such 8 parts. So that's why I have taken here 8 times, right? So that's why we have taken here 8 times. So that is why we have taken here 8 times, right? So now let us integrate. You see this r square into r square, that width. As you can see, here you see, let me write. So what we're going to do, that r square plus r square into r square, that's going to be r to the power 4, right? That's going to be r to the power 4, right? R to the power 4. So if we integrate this, then what will happen? So if you integrate this, that r square into r square, that's equal to r to the power 4. If you integrate this, then what you're going to have? And then you will get r to the power 5. So you will get this r to the power 5 by 5, right? R to the power 5 by 5. So this is pi by 2. Pi by 2. Okay. Then we have to integrate it from 0 to capital R. Radius is r, right? Then remaining part is this. Now next time we are going to integrate this sine theta d theta. Then you will get, what you're gonna get, minus cos theta. So it is from 0 to pi by 2. Then if you put here pi by 2, you will get minus cos pi by 2 minus plus cos 0. Cos 0 is 1, and here this is nothing but 0. So that's why we will get this 1, right? And then d phi 0 to pi by 2. So in the next step we're gonna get this, right? So this is equal to 1 minus cos theta. From 0 to pi by 2 it becomes 1, right? So hope you have understood this. So now phi from 0 to pi by 2, if you put pi by 2 minus 0, then you will get this, right? So this is the volume of the sphere. That's how we can solve. So hope you have understood this. Now let's move on to the next question. So here the question is, what is Poisson's distribution, and calculate the mean Poisson's distribution. So here you see, let me write the definition. So this is the definitions of Poisson distribution, that Poisson distribution is limiting form of the binomial distribution. You have already got binomial distribution, where probability of an event in one trial is very small and number of trial is very large. Then this is the expression is given by P of R, m to the power r e to the power m minus m by r factorial. So here these are the meaning of the terms used here, right? I have written here. So now you see how to calculate the next part of the question is mean Poisson's distribution. So how to do that? So P of R, this is the expression for Poisson's Poisson distribution. Then now you see, for r is equal to 0, P of R becomes this. If you put r is equal to 0, then m to the power 0 e to the power minus m by 0 factorial. So then P of R dot that means into r will be 0, right? So if you multiply this one with 0, then you will get 0. So hope you have got this. So now if you put r is equal to 1, then you will get this. Factorially 1 is 1 simply, so you will get this. So P of r into r will be this one. Then if you put r is equal to 2, then you will get here m square e to the power minus m by 2 factorial. And here, so you see, if you multiply this one by 2, then you will get this result, right? Then if you put 3 here, you will get this result. So here you see, if you multiply it by 3, factorial 3 means 3 into factorial 2, right? 3 will be cancelled, so we have got this factorial 2, right? So similarly for r, you will get this expression if you go on, right? This factorial r minus 1. What we have done here. So now you see, if you multiply here r, then you will get this factorial r minus 1, right? So now you see, to find the mean, we need to take the summation of P of R into PR, P of R into R, summation of that, and divided by the summation of PR. So first let me find this one, summation of P of R into R in the next slide. So here is the summation. If you add all the terms, then you will get this. So from here you can take common m into e to the power m minus 1, and you're gonna get this series. So this is exponential series, right? And this is nothing but this series is equal to e to the power m, and if you multiply e to the power minus m and plus m, e to the power plus m, then you're gonna get e to the power 0, which is equal to 1. So 1 into m is m, right? So similarly you can find sum of P of R. Then what you get, that's gonna be 1, because all elementary events, probability of all elementary events is always sum of the probability of all elementary events is 1. So here sum of P of R is equal to 1. So that's why the mean of the Poisson distribution will be given by sum of PR into R, P of R into R, divided by sum of P of R, that is m by 1, that's going to be m, right? That's how we can calculate. So hope you have understood this. So if you have understood, please hit the thumbs up button, and if you are new to my channel, subscribe the channel and share with your friends. And see you in the next video. Stay connected, and also hit the bell icon so that when new video will be uploaded, you get notified. So thank you for watching. See you. Take care.